Okay, so this is Unit 2 in Geometry. The unit is called Logic and Proof, and this is the first lesson. The first lesson is called an Introduction to Logic and Proof. So we have a few definitions to start with. The first definition is called a conjecture. Okay, a conjecture. It is an educated guess based on known information. This next definition is called inductive reasoning. Inductive reasoning. It's reasoning that uses a number of specific examples to arrive at a prediction. Okay, one more definition now is called a conditional or a conditional statement. Okay, I'm just going to say a conditional. A conditional is another name for an if-then statement. For example, if you are not completely satisfied, then your money will be refunded. Conditionals have two parts. They have the part that follows the word if. I'm going to say the part following if is called the hypothesis. And then the part following the word then is called the conclusion. Okay. Example 1, identify the hypothesis and the conclusion. If two lines are parallel, then they never intersect. So the hypothesis will be what follows the word if. So you don't write the word if. I'm just going to say hypothesis is two lines are parallel. And for the conclusion, I'm going to say they never intersect. Okay, example 2, write each sentence as a conditional. So you have to write it in if-then form. So this example, a rectangle has 4 right angles. I'm going to write it, I'm going to say, if a figure is a rectangle, then it has 4 right angles. If a figure is a rectangle, then it has 4 right angles. Okay. Part B, an obtuse triangle has exactly 1 obtuse angle. Just make sure your sentences sound good. I'm going to say if a triangle is obtuse, then it has exactly 1 obtuse angle. Okay? If a triangle is obtuse, then it has exactly 1 obtuse angle. Okay, second page. Every conditional statement has what's called a truth value of true or false. Every conditional statement has a truth value, and which is either true or false. To show a conditional statement is true, you must show that every single time the hypothesis is true, the conclusion is also true. It has to work every single time for it to be true. To show that a conditional is false, you only have to find one. It's called a counterexample. But when the hypothesis is true, the conclusion is false. Okay? You only need one counterexample. If it's not true every single time, then it's false. It has to be true every single time. So you only need one counterexample to disprove a conditional statement. Okay? Example 3. Show that the following statement is false by finding a counterexample. If it is February, then there are only 28 days in the month. So that is false, and a counterexample would be a leap year. So I'm going to say counterexample. I'm going to say February has 29 days and a leap year. I think it was a leap year in this year, 2020, I think. Yeah, it was. That's called a counterexample. Another definition, it's called the converse. The converse of a conditional statement switches the hypothesis and the conclusion around. Okay. So next example, example 4. Write the converse of the following. If two lines intersect to form right angles, then they are perpendicular. So the converse, you're going to switch the hypothesis and the conclusion around. I'm going to say, if two lines are perpendicular, so make sure your sentence sounds good. If two lines are perpendicular, then they intersect to form right angles. And now I'm going to pose this question. Is it possible for a conditional and its converse to have different truth values? Can one be true, and then when you write the converse, it's false? Or the other way around, where one is true and one is false? The answer is yes, is possible. So let's look at an example. Example 5, which conditional statement has a false converse? So these statements are all true, but which one has a false converse? Part A, if you switch it around and you say if two planes have no points in common, then they are parallel. That's also true, so the converse is true. Part B, if a point lies on the y-axis, then it has an x-coordinate of 0. That's true. Part C, the converse, if you have a figure that has 4 sides, then it is a square. That one is false. So I'm going to say choice C has a false converse. Okay? I'm going to say a counterexample is a rectangle. Again, the converse, if a figure has 4 sides, then it is a square. It could be a 4-sided rectangle, it could be a 4-sided rhombus, it could be a 4-sided parallelogram. So that one has a false converse. And D, the converse, just to check it, if two angles have the same measure, then they are congruent. That's true. So the answer is C. C has a false converse. Okay, next page. Okay, so we went over conditionals, we went over converses. The inverse is when you negate or take the opposite of both the hypothesis and the conditional, the hypothesis and the conclusion, I should say. And the contrapositive is when you switch around the hypothesis and conclusion and take the opposite of each. So if you want to look at it in symbols, if we say P, that means P implies Q is your conditional statement. The converse is when you switch it around and you say Q implies P. The inverse is when you take the opposite of P, implies the opposite of Q. And the contrapositive is when you switch them around and you say the opposite of Q implies the opposite of P. Okay, so let's try this next example. First, linear pairs are supplementary. First, let's put that in if-then form. So I'm going to say conditional. If two angles form a linear pair, then they are supplementary. Then it says, determine whether it's true or false. If it's false, find a counterexample. So this one is true. Let's do a converse next. Converse, switch around the hypothesis and conclusion. If two angles are supplementary, then they form a linear pair. That is false. So my counterexample, I'll do this. Let's say this angle is 120 degrees. Let's say this angle is 60 degrees. Well, those two, right there, that's my counterexample, okay? Because these two angles are supplementary because they add to 180, but they do not form a linear pair because they're not right next to each other. They would form a line. So this is my counterexample. You can have a picture as a counterexample. That's my counterexample. So the conditional is true, converse is false. Now let's do the inverse. The inverse is when you take the opposite of the hypothesis and the conclusion. So I'm going to say if two angles do not form a linear pair, then they are not supplementary. If two angles do not form a linear pair, then they are not supplementary. That is false. So for my counterexample, I'll do the same diagram as before. Let's say this is 120, this is 60. Well, these two angles do not form a linear pair, but they are supplementary. So that's why the inverse is false. So the conditional is true, converse is false, inverse was false. Now let's do the contrapositive. If two angles are not supplementary, then they do not form a linear pair. If two angles are not supplementary, then they do not form a linear pair. Okay. When a conditional statement and its converse are both true, they have to both be true, the conditional and the converse. You can combine them into one statement. It's called a biconditional. Biconditional. Bi means two. Biconditional, two conditionals. You can either write both sentences with the word and in the middle, but that's a little messy sounding. So you can combine them into one statement with the following phrase. The phrase is if and only if. An abbreviated IFF if you want. Right, so let's do a couple examples on that. Write the converse of each conditional. If the conditional and its converse are both true, you can combine them as a biconditional. Conditional, if two angles have the same angle measure, then they are congruent. That's true. Let's write the converse. Converse is if two angles are congruent, then they have the same measure. If two angles are congruent, then they have the same measure. Now you want to think if both of those statements are true or not. I'm going to say both the conditional and converse are true. Since they're both true, you can write what's called a biconditional. So here's the biconditional. Two angles have the same measure. I'll say this is my biconditional right here. Two angles have the same measure. If and only if, that's the key phrase. If and only if they are congruent. Now we're going to go the opposite way. For example 8, I'm going to give you a biconditional, and you have to write two statements from that. Okay, so example 8, write two statements that form this biconditional. A number is divisible by 3 if and only if the sum of its digits is divisible by 3. Write two statements from that. My first one, if a number is divisible by 3, then the sum of its digits is divisible by 3. Then I'm going to say if the sum of a number's digits is divisible by 3, then the number is divisible by 3. On the previous page, I was using those letters P and Q for these, so, I mean, a biconditional combines P implies Q and Q implies P into this. P implies Q, Q implies P, like that. One statement. Okay, the last page. It's a pretty long lesson. There's not much math involved, just writing. A conjunction is a compound statement formed by joining two or more statements with the word and. Okay? In order for a conjunction to be true, both parts must be true. And means both parts must be true. A disjunction is a compound statement formed by joining two or more statements with the word or. Okay? You only need one part to be true for a disjunction to be true. For a conjunction, both parts must be true. For a disjunction with or, you only need one part true. So example 9, state whether the following conjunctions are true or false. Blue is a color, and 7 plus 3 equals 10. Okay, so both parts are true, so the answer is true. Part B, 1 minute is exactly 60 seconds. That's true. And 1 hour is exactly 55 minutes. That part's false. Okay, so the first part is true, the second part is false. That means the entire thing is false because it has the word and in the middle. Both parts must be true when it says and in the middle. And part C, 3 plus 4 equals 6, and all dogs are brown. Both parts are false. So that one is false. Now, example 10 is for disjunctions. So we only need one part to be true. That's it. One part or both. We only need one or both. So example 10, blue is a color. That is true. Or 7 plus 3 equals 10. They're both true. So that means it's true. Part B, 1 minute is exactly 60 seconds. That's true. Or 1 hour is exactly 55 minutes. That's false. So the first part is true. The second part is false, but this one is still true because it's a disjunction, so we only need one part to be true. So that one is true. And part C, 3 plus 4 equals 6, or all dogs are brown. Both parts are false, so that one is false. So not a lot of numbers involved today, but that is the first lesson in this unit called Introduction to Logic and Proof.